first problem in exercise 2.2 is, for what values of natural number n, 4 power n can end with the digit 6. Okay, so what we have to do is, for natural number n, 4 power n can end with the digit 6 or not. Let us check. So to check that, what will we do? We have to write the factors of 2. We have to write the factors of 4 in terms of prime numbers. So 4 can be written as 2 into 2 power n, which is 2 power n into 2 power n, because this power is common to both the numbers. So it can be expressed as 2 power n into 2 power n. So 2 is a prime number which is also a factor of 4. So 4 power n is always even. 2 power n, which is a factor of 4, and is also even. Therefore 4 power n is also always even. So when n is an even number, 4 power n can end with digit 6. Yes, we got the solution. Whenever n is an even number, 4 power n will end with the digit 6. Let us cross check. 4 power 1 means 1 is an odd number. 4 power 1 is 4, which doesn't end with 6. Next we will choose 4 square. 4 square is 16. N is an even number and it has ended with the digit 6. 4 cube. 4 cube is 4 4s are 16. 16 into 4, 64. It doesn't end with 6, where 3 is an odd number. Next we will choose an even number, 4 power 4. 4 power 4 will give us 256. N is an even number and it ends with the digit 6. It goes on like this. So whenever n is an even number, 4 power n will end with the digit 6. Next problem is, m and n are natural numbers. Now what we have to find is, for what values of m, does 2 power n into 5 power m ends in 5. That is the product of these two. For what value of m it ends in 5. That is what we have to check. Let us check whether it will or not. So solution, first we will take the factor 2 power n. So 2 power n means for any value of n, 2 power n is an even number, because 2 power 1 is 2, 2 square is 4, 2 cube is 6, it goes on. So 2 power n is always even for all values of n. Next, 5 power m is always odd and ends with 5 for all values of m. See, 5 power 1 is 5, it ends with 5. 5 square is 25, which is an odd number, also ends with 5. Next, if I choose 5 cube, where m is an odd number and 5 cube will give us 125, again it ends with 5. So this is the conclusion we got from these two. Now what we have to check is whether the product of these two ends in 5. Now 2 power n into 5 power m is always even, because the combination of odd and even will give us 2 power n into 5 power m is always even and ends with 0. Let us check that. If I choose the value of n as 1 and m as 2, what will I get? 2 into 5 square is 25, which is 50. So it is an even number as well as it ends with 0. So what is the conclusion is, this number 2 power n into 5 power m will not end with 5 for any values of m. Therefore 2 power n into 5 power m cannot end with 5 for any values of m. Next question is, find the HCF of these two numbers. As I already told you, we'll use the Euclid division lemma to find the HCF of these two numbers, and among these two numbers the largest number will be considered as a dividend and the smallest number will be considered as a divisor. So this will consider as a value of B and this will consider as a value of A. By Euclid's division lemma, it can be expressed as A equals to BQ plus R. A value is the dividend 36, 36, 36 and B is the divisor 25, 25, 25. We will have to find the HCF of these two numbers. First we have to divide this number by this number. 36, 36, 36 is divided by 25, 25, 25. 1 times 25, 25, 25. Remainder is 1, 1, 1, 1, 1, 1. So this number into 2 times plus remainder value is 1, 1, 1, 1, 1, 1. Okay, so next what we have to do is, we haven't got the remainder as 0. We have to proceed with the procedure. So while proceeding with the procedure, this will become the dividend and this number will become the divisor. So doing it so, 25, 25, 25 which is equals to, now we have to divide this number with this number. Let us do it so. Is divided by, so let us choose 2 times. Remainder will be 3, 0, 3, 0, 3. So, into 2 times plus the remainder is 3, 0, 3, 0, 3. Again the remainder is not equals to 0 in this. So, we have to proceed with the Euclid's division algorithm. So, now this will become the dividend and this will become the divisor. Proceeding in the same format, what will we get? Divided by 3, 0, 3, 0, 3. We can choose 3 times. 9, 0, 9, 0, 9. So it will become into 3 plus 2, 0, 2, 0, 2. Again the remainder is not equals to 0. We have to proceed Euclid's division algorithm. Now this number will become a dividend 3, 0, 3, 0, 3 which is equals to, this will become the divisor 2, 0, 2, 0, 2. So let us proceed. So 3, 0, 3, 0, 3 which is divided by 2, 0, 2, 0, 2. We will choose 1 times 2, 0, 2, 0, 2. The remainder will be 1, 0, 1, 0, 1. So 2, 0, 2, 0, 2 into 1 plus 1, 0, 1, 0, 1. The remainder again is not equals to 0. We have to proceed with the same format. Now this will become a dividend 2, 0, 2, 0, 2 and now this will become a divisor 1, 0, 1, 0, 1. Let us try it. So 2, 0, 2, 0, 2 divided by 1, 0, 1, 0, 1. So we will choose 2 times. It will become 2, 0, 2, 0, 2. The remainder is 0 into 2 plus 0. So we have got the remainder as 0. In the same point, the divisor will be considered as a HCF of the two numbers. Therefore, HCF of 3, 6 and 2, 5, 2, 5, 2, 5 is 1, 0, 1, 0, 1. Next question is, if 13824 is expressed in the format 2 power a into 3 power b, then we have to find the values of a and b, and it is easy to find. What shall we do? We saw the same format problem in example also. We will follow the same steps. Now we have to find the factors of 13824 in terms of prime. Let us do it. So 13824 can be divided by the 2. It will become, next again this can be divided by 2. This number also can be divided by 2. Again can be divided by 2. Can be divided by 2. Now 431 cannot be divided by 2. We have to choose the, 432. It can be divided by 2 and it can also be divided by 2. 108 can also be divided by 2. 54, 27. 27 cannot be divided by 2. Therefore, we have to choose the next prime number. We have to choose 3. 9 times, again choosing 3 times. So this can be expressed as 1, 3, 8 to 4 can be expressed as 2 in 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 power 9 into 1, 2, 3. 3 cube. Now comparing with the given format, we can find the values of A and B. In place of A, we have 9. So therefore A equals to 9, and in place of B we have the value as 3. Therefore B equals to 3. Hence found. Next question is, it is given in the format P1 power x1 into P2 power x2, P3 power x3, P4 power x4, which is equals to 113400. The number is expressed, where in this P1, P2, P3, P4 are all primes and x1, x2, x3 are all integers, whereas prime is in an ascending order. Okay, so that has to be noted. Now we need to find the values of P1, P2, P3, P4 and x1, x2, x3, x4. Now what we have to do is, we have to express this number in such a format. Then we can compare the values we found and the format given in the question. We can find the values of all these 8 things. Okay, so we will factorize this number 113400. As I already told you, we have to start with the least prime number, which is 2. Also here it is mentioned as in ascending order. Okay, will be 56700. Again it can be divided by 2. 2 times 4, 8, 3 times, 5 times 0. Again it can be divided by 2. 1 times, 4 times, 1 times, 7 times, 0. 14175. Again it can be divided by, now it cannot be divided by 2. We have to choose the next prime number. We can choose 3. If 14175 it is divided by 3, we will get 4725. So next also we can choose the same prime number 3. Dividing 4725 divided by 3 will get 1575. Again we can choose 3. 5 to 5. Again we can choose 3. We will get 175. So 175 cannot be divided by 3. So we will choose the next number, which is 5. So 35. Again 5, 7. So 7, 1. So now we can write the number in this format, which can be written as 113400, which is equals to 2 power 3, because we have 2 3 times. Next we have the prime number as 3 and it has appeared 4 times. So 3 power 4. Next we have the prime number 5. It has appeared 2 times. It can be written as 5 square. Next prime number we have is 7. 7 power 1. We have only 1 times. Now we are going to compare with this format. Okay, as I already told you, we have expressed this number in such a format, whereas what we have expressed and what is given are the one and the same. Okay, in place of P1 we have the value of 2. So P1 equals to 2. In place of P2 we have value as 3. So next is in place of P3 we have the value as 5. Next in place of P4 we have the value as 7. P4 equals to 7. Similarly, in place of x1 it is 3. In place of x2 it is 4. In place of x3 it is 2. In place of x4 it is 1. So thus we have found out the values which we have been asked to find. Next problem is, we have to find the LCM and HCF of both the numbers 408 and 170. Now we have to apply the fundamental theorem of arithmetic. So obviously if it is a fundamental theorem of arithmetic, we have to express this number as a product of one or more primes. So first what will we do is, we will find the factors of 408 and 170. 408, the factors of 408 are, so we'll choose the least prime number 204. So it can be again factorized by 2, 102. It can be again factorized by 2, 51. Now it cannot be factorized by 2. We have to choose the next prime number. Factorized by 3, 17 times. 17 is a prime number. We'll stop with this. So 408 equals to 2 cube 3 power 1 into 17 power 1. So 408 is expressed as the product of one or more primes. Similarly, the same will do it for 170. So 170 can be expressed as, we'll choose 2. So divided by 2 we'll get 85. So divided by 5 we'll get 17. 170 can be expressed as 2 power 1, 5 power 1 into 17 power 1. We have expressed the factors of both the numbers. We have to find the LCM and HCF. So first, to find LCM, we have to write all factors of 408 and 170 of their greater exponents. What does it mean is, when to find an LCM, what we have to do is, we have to write all the factors of both the numbers. But one thing is, we have to consider the greater exponents. For example, both as the factors 2. But when comparing, this has the highest power. So, when finding the LCM between 408 and 170, first we have to consider 2 cube, because among these two, this is the greatest exponent. So, we are considering 2 power 3. Next, we have 3. It is only 1 time. So, it will also be included. Next, we have 5. It is also power 1. So, we include 5. Next, we have 17. Both as power 1 only. So, we have to consider 17. Next is 2 cube is 8 into 3 into 5 into 17. We have to simplify this. 8 3s are 24. 24 into 5 will give us 20, 2 balance, 10, 12. So now 17 into 120, 120 the 17. So 14, 1 balance, 2, 3, 7, 1, 4, 10, 1. So 2040. LCM of 408 and 170 is 2040. Second point is, to find HCF, we have to consider the factors, common factors of 408 and 170. So HCF is equals to, what does it mean by common factors in the sense, I have 2 3 times here, 2 1 times here. So 2 1 times is only present in both the numbers. So we have to consider only 2 1 times. And 3 it is present over here, but it is not present over here. We will not consider it. Next 5 is present over here, but it is not here. So we will not consider it. 17 is present in both the numbers as well as it is present only 1 time. So we will consider 17 also, which is common in both the numbers only we will consider. So 17 into 2 it is 34. HCF is 34 for the given problem. Exercise 7th problem. We have to find the greatest number consisting of 6 digits. So we have to consider the 6-digit greatest number, which is exactly divisible by the numbers 24, 15, 36. So we will find this greatest number. To find the greatest number also, we will use the fundamental theorem of arithmetic. We have to find the LCM of these 3 numbers. Before finding the LCM of these 3 numbers, what we have to do is, we have to find the factors of these numbers. So first we will find for 24, 15 and 36, we will find LCM then. So for 24 it is 2 times 12, 2 times 6, 2 times 3, 3 times. So 2 cube into 3 power 1. And for 15 it is 3 times 5, 5 times 1. So 3 power 1 into 5 power 1. Choosing only prime numbers. Next for 36 it is 2 times, 36 it is 2 times 18, 2 times 9, 3 times 1. So 2 squared into 3 squared. So as I told you in the last problem itself, to find the LCM, we have to consider the greatest exponent among these three for all the factors. So let us find the LCM. So among these three, when considering for 2 square, 2 cube, 2 cube is the greatest exponent. So I am considering it as 2 cube. Next, when it comes to 3 square is the greatest component. So we are considering 3. Next, if it comes to the 5, there is only power 1. So 5. We have to simplify this. 2 cube is 8. 3 square is 9 into 5. 9 8 is 72. 72 into 5 will give us 360. So we got the LCM of these three numbers. Next, what we have to do is, we will take the last 6 digit number which we know, that is 9 6 times is the last 6 digit number. We have to divide this number by the LCM of these three numbers. Why it is so is, we are asked to find the greatest number consisting of 6 digits which is divisible by these three numbers. That is why we found the LCM of these three numbers. So we have to divide this 360 by that. Dividing the last 6 digit number we know by 360. Okay, so we can choose 2 times 720, 9, 7, 2. 9, we can choose 7 times 2520. Remaining will be 9, 7, 2. Again we can choose 7 times 2520. Remainder will be 9, 7, 2. Again we can choose 7, 2520, 9, 7, 2. So the remainder value is 279. What am I coming to say this? If I choose the last 6 digit number and divide it by the LCM of these three numbers, I got some number as a remainder. So if I subtract this remainder value from the last 6 digit number which I know, I will get the answer for this question which has been asked. So what is it is, we have to subtract 279 from the last 6 digit number we know, minus 279, which will be 0, 2, 7, 9, 9, 9. So this is the greatest 6 digit number which is divisible by 24, 15 and 36. So which is equals to 999,720. So this number will be divided by 24, it will give a remainder 0. This number will be divided by 15 which will give a remainder 0. This number can be divided by 36 which will give us a remainder 0. Okay. Next question is, we have to find the smallest number when it is divided by 3 numbers 35, 56, 91 and leaves remainder 7 in each case. Okay, so we have to find the smallest number which is divided by these 3 numbers and the smallest number which is divided in all the 3 cases must leave a remainder 7. That is what is the question given to us. The same method we follow. When we are asked to find the greatest number, we got the LCM of 3 numbers and proceeded. Whereas to find the smallest number also, we have to follow the same steps. That is, we have to find the LCM of these 3 numbers first. To find the LCM of these 3 numbers, what we have to do? We have to find the factors of these 3 numbers first. So 35, 56, 91. First for 35, I can choose only the least prime number 5 because it won't divide by 2, it is not divisible by 3 as well. So 5 if I choose 7 times 7. So 5 power 1 into 7 power 1. Next 56, 2 times, 28 times, again 2 times, 4 times, 2 times, 7 times. So 2 cube into 7 power 1. Next it is 91. 91 I can choose the least prime number as 7, 13. Okay, so it can be written as 7 power 1 and 13 power 1. As I already told you, LCM we have to write all the factors of their greatest exponent. Okay, among 2 we have only 2 power 3 that will be included. In 5 the highest exponent is 1, and also in 7 the highest exponent is 1, and in 13 highest exponent is 1. So 2 cube is 8 into 5 into 7 into 13. 8 into 5, 40, 40 into 7, 280, 13 into 280 will give us 8 3s are 24, 2, 8 1s are 8, 10, 2 3s are 6, 2, 4, 6, 3, 0. Okay, so 3640. So we got the number, the smallest number when it is divided by these 3 numbers. But we have one more option to do is when it leaves the remainder 7. If I divide 3640 by 35, I will get a remainder 0. If I divide 3640 by 56, I will get a remainder 0. If I divide 3640 by 91, I will get a remainder 0. But what we are asked to find is, we have to find the smallest number which leaves the remainder 7. So it should leave a remainder 7. For that, what we have to do is, with this number we have to add 7 to it. So we can find the smallest number that leaves the remainder 7 when it is divided by these 3 numbers. So therefore, the smallest number is 3640 plus 7, which is 3647. 3647 leaves remainder 7 when it is divided by 35, 56 and 91. Ninth problem in exercise 2.2, what we are asked to find is, we have to find the least number that is divisible by first 10 natural numbers. So natural number begins with 1. First 10 natural numbers, in the sense it is 1 to 10. Okay, let us find it. For this also we will follow the same procedure. Finding the LCM of all these 10 numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be the least number that is divisible by the first 10 natural numbers. So we will write the factors of all the first 10 numbers. 1 into 1, 2 in times of prime number, 2 into 1, 3, 3 into 1, 4 can be written as 2 into 2, 5 can be written as 5 into 1, 6 can be written as 2 into 3, 7 can be written as 7 into 1, 8 can be written as in terms of only prime, so 2 into 2 into 2, and 9 can be written as 3 into 3, 10 can be written as 2 into 5. So these are all the factors of numbers from 1 to 10. Now finding the LCM of these numbers is nothing but the least number that is divisible by first 10 natural numbers. What is the LCM of these 10 numbers is, for LCM we have to write all the factors of their greatest exponents. So among these, if I see 2 here only 1 times, it is 2 times, and if you look at here it is 3 times. So 2, the highest power among these 10 is 2 cube. Therefore I have to consider only that. Next prime number we have is 3, and also in 3 the highest component is 3 square. So we have to consider only the greatest exponent. Next is 5. 5 we have, everywhere it is power 1. So 5 1 times. Next prime number we have, it is 7. 7 also power 1. So simplifying this, 2 cube is 8 into 3 square, 9 into 5 into 7. 9 8s are 72. 72 into 35. 7 5s are 35. What will it be? 10, 1, 35, 36, 6, 21. So 0, 2, 1, 3, 4, 5, 2. So the number, least number is 2520, which is divisible by all the first 10 numbers. In today's class, we saw the topic fundamental theorem of arithmetic. We have solved greatest number, smallest number, least number, all those things we saw in this section. In the next class, we will see the section modular arithmetic. Thank you.